Okay. Good morning, everybody. My name is Joe. I work at the Centre for the Study of Early Agricultural Societies at the University of Copenhagen. I also really like R, and I'm very happy that we have another session on R this year. The predecessor session to this last year is what really inspired me to take some code that was in pieces on my computer and really try and bring it together and put it into a package that other people can use, because as we saw last year, the Kiel group especially showed that is not really as hard as it sounds, and it's definitely worth doing. But going back to basics to begin with, if we're thinking about the current state of R and its next directions, I think it's worth thinking about why are we using R? Why is it becoming so popular in archaeology? Obviously, a really widely discussed reason is reproducibility, is making analyses more transparent and open. But I think it's also, we should not forget that R itself is a powerful tool. And so even if you take away the reproducibility aspects of it, there are a lot of benefits in terms of taking either methods, statistical methods that are currently used in archaeology, making them easier, making them more rigorous, especially if you're moving from a graphical statistical package like Excel would be the standard platform in archaeology still, I think, to R. Also, because our ecosystem is so big, so diverse, it enables a lot of new approaches that have previously not been known or not been practical to apply in archaeology. And the asterisk here is just to say, I think all these points also apply to other statistical programming languages, Python, Julia. I like R, but it's not unique to R. So with my talk today, I'll be demoing a package I've been developing, fieldwalkr, and trying to point out some ways in which we can advance this agenda of reproducibility and ease of access. So in terms of reproducibility, we've made great strides in archaeology and in social science generally, I think, in making computational results reproducible or replicable. There's a bit of a terminological pointless argument there, but I'll stick with reproducible. So that's sort of starting with open data, using open software, open source software, preferably, to analyze that data and sharing your code. But I think we're all aware that this really comes at the end of an archaeological research project. We start with processes that happened in the past that led to material being preserved or not preserved. And all these steps between then and your interpretation are also places where we can try and improve the reproducibility or the replicability, or at least just openness of archaeological research. So my package is kind of aimed at this early step of recovery methods, sampling, trying to open that up a bit from the perspective of archaeological field survey. Another widely discussed aspect of the popularity of R, I mean, this is a figure that I don't know if Marwick made it, but he uses it a lot, is this idea of researchers having to move from being T-shaped specialists, where you have broad knowledge of a subject area, like archaeology, and then a specialism, to pie-shaped researchers, where you have that broad knowledge, domain speciality, but then also a parallel speciality in computational and statistical methods. I think this is maybe a bit more complicated than this figure implies. I would say that many archaeologists are already pie-shaped because we tend to have a broad background education in archaeology. We then specialize in a period or a region, and then most archaeologists also specialize in a material, like they work on zooarchaeology, ceramics, etc. So then to add computational skills to that, you're really adding a third leg. You're making stool-shaped researches. And I think at that point, you may be starting to go a bit far. I don't know if it's practical to expect most archaeologists to be trained in such a wide range of techniques. Maybe some people can, but not everyone. And I think if it was possible for archaeologists to be domain specialists and material specialists and computational specialists, that would have happened already. We would have seen wider adoption of tools like GIS, which have been around a long time. They have a shallower learning curve than R or scripting languages, and it hasn't happened. So what I would maybe propose as an alternative is that we stick to being pie-shaped researchers and see ourselves, us in this room, as people who specialize in archaeology and in computational methods. And then we can think, okay, if we accept that not everybody is going to use the exact same tools that we use, how can we still make an impact on the wider discipline? How can we make our R packages or other software tools accessible to people who specialize in other areas of archaeology? And I will suggest one very straightforward approach to doing that in R is to create graphical user interfaces. So the Shiny package, for those not familiar with it, is a way to make web-based graphical interfaces on top of R code in a very neat, elegant way. It's very easy to use. I admit I had hoped I would have a fuller Shiny interface to show you today for my package, but I haven't got there yet. But what I will show you is this presentation, which is in itself a Shiny application. It's hosted on shinyapps.io. So it's actually an R Markdown document with embedded Shiny widgets that I hope to one day bring together into a cohesive interface. So the talk is also the object of the talk. So back to the package, fieldwalkr. I think I can go quite quickly through this because those of you who were at Bintliff's talk this morning, what he was talking about was really the kind of issues that led me to want to develop this kind of package. It's thinking about spatial sampling, a well-worn subject in landscape archaeology, but a very complicated one. And when I started doing some surveys and wanted to understand the implications that my sampling techniques were having on my results, I found that there wasn't a good platform for exploring those factors. And that's what led me to develop this R package for simulating and assessing sampling strategies, etc. So fieldwalkr is an R package I would call a simulation framework for surveys, for field walking. It allows you to explore theoretically the effects that different research designs would have on your results before you do it. Also, you can go back, reanalyze survey data you already have, think about whether there are any biases there that might be affecting. And the conceptual framework I've come up with is to divide a survey into three main components. So the first of these is the actual target of your survey. You can model this in many ways, but I think the most versatile one is to model them as a point process. So then you can make use of point pattern analysis based statistical methods. So one wing of the package is to model the many different things that can affect the distribution of point data in archaeology, whether that's sites or individual finds or something in between. And this is where a lot of the inputs of the package come in. So you can use real empirical data if you're doing a reanalysis, or you can do some more theoretical random processes. Then we have what I call the sampling function. So all the various decisions you make when you're sampling a landscape, unless you have 40 years to survey it all, which would be nice, but not practical in most cases. So, all these decisions: where do you survey? How do you divide up the area? Which units within that do you select? And then a third and very, very important corollary to that is the concept of detection function, which is I've taken from the work of Ted Banning in Toronto. So these are all the things that affect the probability of recovering your target archaeological sites or archaeological material where you do sample. And yes, so it's implemented in R. Don't think I need to argue for why R is a good idea in this session. But well, just to say that I also tried to take a very contemporary approach to R, so using tidyverse, using functional programming, and this whole design paradigm. So I will quickly run through a demo of the package. It's currently on GitHub. It's not on CRAN yet. Hope to get there soon. A couple of the main dependencies are the tidyverse, the SF package for updated spatial analysis in R, and also this random fields package is also very good for working with field data and modeling fields. I say an old friend with SpatStat is actually quite key to the package, but I personally think it's showing its age, and there are some difficulties getting it to work with these other paradigms. So to take you through a typical analysis, you start with the area you want to survey. In this case, I'm just generating a random blob. Then you have your target data. Again, we'll generate some randomly. This might be a scatter of sites. If we up the intensity of this log Gaussian Cox process that generates the sites, we could say, okay, maybe this is more like an artifact scatter, more dense. We'll eventually get there. Then we have various ways of dividing up the area, modeling our sample frame. So mosaic, like a field system, or transects. It always does that. Grids. So grids, change your number. Maybe you don't sample all of them, you do a random sample of 50%, etc. So then, just to step out of the demo for a minute, the widgets, the shiny widgets that I've just shown, are very easy to put together in R. You simply have this way of defining the inputs, and then Shiny takes care of all the layout for it nicely and automatically. Then there's some logic that maps those inputs onto fieldwalkr functions. So in this case, functions for different types of sample frames. And then finally, we just have a simple plot, ggplot based, that will refresh as you change the form. These are what the detection functions look like. I've actually changed these quite a lot since I did this presentation. So if we just stick with a simple detection function that says, okay, we detect 70% of the sites in our survey areas, we can then simulate a survey, say, okay, these are the kind of results we would get. And then we can start to do some analysis. So some simple statistics you can make is, okay, how many sites have I managed to recover, percentage, given the parameters of the survey that I've just run, or taking advantage of the fact that we actually specified our point pattern as a mathematical model at the beginning. We can say, okay, it's not so important how many we got, but how accurate is our understanding of the spatial pattern. So if we can compare an estimation of the point process to the ones that we knew we actually gave it, see how close the parameters are And then here I think the real benefit of R comes in that is that you don't want to do what I've just done once. You want to do it 100 times with 100 different options. Really explore the parameter space of the survey, and maybe end up with something like this. So, here just altering the amount of coverage that we do in the sense of the proportion of survey units that we select. See how that affects the root mean square error of our model estimation. And so in this high example, we'd see actually going beyond 50% coverage does not give us really any more significant information. So that's a quick run through fieldwalkr. If you're interested, it's on GitHub, ready to be installed using the DevTools install GitHub function. This presentation is also on GitHub, the code, or if you don't fancy trying to get RStudio to build it, you can see it live on Shiny Apps. Thank you for listening.